right, let's go back to 6th grade and 8th grade where we learned how to solve 1- and 2-step equations, what's commonly known as solving for x. So let's start off with a pretty straightforward example. I'm thinking of a number, it's a mystery to you, that I subtract 5 from it and it gives me 2. What's my mystery number? Hopefully a lot of you said 7. And the reason why is because 7 minus 5 equals 2. Now in algebra, writing mystery number again and again and again will take a long time. So what we like to do instead is we like to write a letter to represent my mystery number, a variable known as x. And whenever you see a problem with an x in it, just think that x is a number. Maybe you know what it is, maybe you don't know what it is. Yes, many of you said that x is 7 because 7 minus 5 equals 2. But I want you to start thinking backwards. Maybe x equals 7 because 2 plus 5 equals 7. Subtracting and adding are what are known as inverse operations of each other. All right, new mystery number. I'll call it y. 4 times this mystery number equals 44. In other words, what number, when I multiply it by 4, gives me 44? Well, most of you are thinking 11 as the correct answer. Now, as I said before, you're not going to be writing mystery number over and over again. We're going to pick a letter to represent the mystery number. How would I write this scenario in algebra language? I would write 4y. That literally means 4 times y, or 4 y's. So yes, 4 times 11 equals 44, but think of it the opposite way. 44 divided by 4 gives you 11. Division and multiplication are inverses of each other. All right, we're going to do one more one-step equation here. There's some number t that I don't know, it's a mystery number, that when I square it gives me 81. In other words, what length of a square would give me 81 tiles? Well, what number times itself gives you 81? Well, the answer is 9. Another way of looking at it is that the square root of 81 is 9. The opposite of squaring is a square root. So these are the inverse operations. Up until now, we learned that addition and subtraction are inverses of each other, and they can help me solve these one-step equations. Multiplication and division are inverses of each other, and they can help me solve these equations. And that square root and squared are inverses of each other. All of these processes are called algebra, and I want to kind of give a history of what algebra is. Algebra was invented in the late 8th century by a Persian Muslim man named Muhammad ibn Musa al-Khwarizmi. He lived in Iraq. He was the head of this big public library called the House of Wisdom. It was a center of learning. And he did these mind exercises of figuring out mystery numbers using a process that he called Algebra. And Algebra means restoration. And in this case, he's saying restoring the balance. His process, known as Algebra, which is an Arabic word meaning restore, got translated into Latin and then moved into Europe. And that's when people called this processes that he invented algebra. So what is the algebra or the algebra process? The Al-Khwarizmi method says, imagine every equation as a balance beam, where the left side of the balance is the left side of an equation, the balance itself is the equal sign, and the other side is the right side of an equation. And there's one rule. The beam must remain balanced at all times. So take, for instance, 3x plus 2 equals 6 plus 2x. The left side of the equation is the left side of the beam, and the right side of the equation is the right side of the beam. And as long as you do the same process to both sides of the balance, it will always remain equal. And this methodology helps us solve for unknowns. And what I'm going to do right now is go through the first three examples we did using the Algebra method. All right, so our first example was x minus 5 equals 2. I want to do the same process to both sides of my balance. I do that by doing the opposite of minus 5. And the opposite of subtraction is addition. I'm going to add 5 to the left side of the balance, and I'm going to add 5 to the right side of the balance. The reason why I do that and why that helps is because 5 and negative 5 become 0. It's like I'm adding 0 now to the left side. And my right side is 2 plus 5, which is 7. Well, basically, I've solved it now because x plus 0 is x, and 7 is 7. And now I know that my unknown value, x, is equal to 7. I'm going to box in my answer. Let's do the next one. 4 times y equals 44. The opposite of times, the opposite of multiply, is divide. But when you divide, make sure you divide the entire side of both sides of the equation. And you do it on both sides, right? 4 divided by 4, well, that equals 1. Y. And over here we have 44 divided by 4, and that's 11. And here it says 1y is 11. I might as well just say y is 11. And that's my answer. Coming over here, I had t squared equals 81. What's the opposite of squaring? Rooting. I'm going to root the left side of my equation, and I'm going to root the right side of my equation. The root of a square returns the normal number, and the square root of 81 is 9. That is my final answer. All right, let's do some questions. On the left side of my equation, I have x and 3 red marbles. And on the right side of my balance, I have 7 marbles. How many marbles are in that envelope? Well, you can clearly see that there's going to be 4. Let's use the Al-Khwarizmi algebra process. We are going to remove 3 marbles equally from both sides. That means the balance is still balanced, and that gives us x equals 4. Let's show what that would look like on paper. On the left side, I had my mystery number and 3 marbles. On the right side, I had 7 marbles. I took away 3 from the left side, and I took away 3 from the right side. That got rid of the 3 on the left side, leaving me with my mystery envelope, and 7 minus 3 is 4, which was what the answer was. In our next example, we have a mystery box named M. On the left side of my equation, I have 2 m's, and on the right side of my equation, I have 4. How much is each m box worth? Well, I can't take away things that are the same thing now from both sides. However, what I can do is I can equally divide both sides by 2. And by doing that, I clearly see that 1 m is equivalent to 2. Let's see what that looks like on paper. I had 2m on the left side of my equation, and I had 4 on the right side of my equation. By dividing both sides by 2, I'm going to show that by drawing a line on both sides and dividing by 2. And remember, we got to do it to both sides. The reason why that works is 2 divided by 2 is 1, so now I have 1m, and 4 divided by 2 is 2, and there you can see my answer is 1 m box is equal to 2. And I'm going to box in my final answer. Let's upgrade to 8th grade algebra, where we're going to have 2 steps to solve something. In this example, we have 2x plus 4 equals 12. In this example, the more clear thing to do would be to take away 4 from each side of the balance, which makes it a little bit simpler to look at. And now we're back to a 6th grade problem. Now I have 2x equals 8. How much does each x equal? Well, if I divide both sides of the equation by 2, I can see that each x is 4. Let's see what that looks like on paper. Here's our original problem. 2x plus 4 equals 12. This is method 1. So in general, we took 4 from each side. So basically, I subtracted 4. That becomes 0 because 4 minus 4 equals 0. That leaves me with 2x on the left side, and it leaves me with 8 on the right side. And then, both sides of the equation, I divided by 2. 2 divided by 2 equals 1, so I have 1x on the left side, and 8 divided by 2 is 4, and I got the same answer. However, there is another method of doing it, not one where we deal with the 4 first, but we deal with the 2. Before I do anything with this 2, I need to look at the relationship it has with x. It's 2 times x. So one thing I could have done was I could have divided both sides by 2. But here's the thing about division. When you divide the equations, you have to divide the entire side. And we're going to divide the entire side by 2. In essence, that's going to give me a 6 on the right side of the equation. And over here, I have a pretty complex fraction. I'm going to break it up into 2 parts to make it simpler to look at. Over here, I have 2 divided by 2, which will give me 1 times x, meaning 1x. And over here, I have 4 divided by 2, which gives me 2. And on the right side of the equation, I have 6. And now we have that 6th grade problem of a number plus 2 equals 6. I'm going to subtract 2 from this side and that side. And that gives me an answer of 4. They both give me the same answer. In this example, I subtracted first on both sides and then divided. In this example, I divided on both sides, but I had to divide the whole side and then I subtracted. As you can see, the order in which you do it has no effect on the answer. Let's kind of visualize that method 2 using some animations here. So if I divide both sides, remember, we're dividing everything by 2. And then we remove half of the balance, and we have our simple problem of x plus 2 equals 6. From there, I remove the 2, and I still get x equals 4. Okay, let's do some examples, but in this example, we have x on both sides of the equation. And at this point, I'm going to move beyond simple animations, and we're just going to do everything by paper. But before I move to the paper, I want to tell you the strategy while you have this beautiful picture up in front of you. This is complicated because our unknowns on both sides. The strategy was to make sure that all of our unknowns are on the same side. And the way you could do that is by getting rid of one yellow bag on each side. Here it is on paper. I had 2 yellow bags. I had 6 marbles on the left side. On the other side of the equation, I had a yellow bag and 9 marbles. Let's remove a bag from each side. X minus x becomes 0. 2x minus x, that's just 1x. And now my problem is a lot simpler. I have an unknown bag plus 6 marbles equals 9 marbles. Well, what's the opposite of adding? Subtracting. I'm going to subtract 6 from both sides of my equation, and I'm going to get x equals 9 minus 6, which equals 3. Now, how do I know my answer of 3 is correct? Well, I'm saying that each of these bags have 3 marbles in it. I'm saying that x equals 3. If that's true, I can go back to my original problem, either the original equation or the original graphic, and I can show that putting 3 marbles in each of those bags would make a balanced equation. Like 3 plus 9 is 12, and 6 plus 3 is 9 plus 3, which is also 12. And since I have equal numbers of marbles on both sides, I know my answer is correct. Our next one is 3b plus 1 is equal to 2b plus 7. When your unknown is on both sides, try to remove the unknown from both sides and make sure our unknown value is left on one side. So the best way to do it is get rid of 2 bags on the right side and 2 bags on the left side. That cancels out. 3 bags minus 2 bags is 1 bag. And now I have a lot simpler equation to solve. My unknown plus 1 equals 7. I subtract 1 from both sides. 7 minus 1 is 6. which is my answer.